Hey there, it's Luke. Welcome back. And today I'm going to be talking about implementing OSPF. So OSPF is a dynamic routing protocol, which means it's automatically updating. Once you've configured it, the routers will exchange information and add all the routes to the routing tables by themselves. And this is good for a few different reasons. It saves us a lot of work configuring all the static routes. Um, it automatically updates whenever you make like changes to the network, which static routes don't. And it's also helpful for finding like alternate paths and load balancing. So we're going to be implementing it on this network right here. Let's take a look at it. It's just a simple network of 5 routers connected in a loop. We have a .10 network, 20, 30, 40, and 50 network. And we have IP addresses for each of the interfaces. If you don't know how to read this, the IP address for this interface is going to be 192.168.10.2, and the IP address for this interface is going to be 192.168.50.1. So there's actually 2 ways to configure OSPF. The first one we're going to be talking about is to configure on the router itself for the entire router, activate OSPF for this entire router. The second way is to configure it on the interfaces. So I'm going to be showing you the first way, and then afterwards I'm going to come back and show you the second way. As you can see, I've already configured all the IP addresses for the interfaces here. So we can just go ahead and get into configuring OSPF. So once we're in configuration terminal, once we're in configuration mode, the first thing we're going to do is begin the OSPF process. And we do that with the command router, OSPF, and then your process ID. This is just a number. I'm going to keep it simple and make it 1 for all of these routers. There we go. We've created the OSPF process, and if you notice, we're now in config router mode, right? So if you ever want to go back and change configurations to OSPF, you can just type this command again to get back into the process. So next thing we want to do is set the router ID, router-ID 1.1.1.1, because we're on this router, right? I'm going to refer to this router as router 1, this router as router 2, 3, 4, and this one as router 5 because the ID is 5.5.5.5. Just for simplicity's sake, even though the label here says router 2, just ignore that. 1, 2, 3, 4, and 5. So router ID 1.1.1.1. So we set the router ID for this. This step is kind of optional. If you don't do it, well, the OSPF process will automatically assign an ID once you like start configuring other things on OSPF. But it's a good habit to have. And then the last thing we need to do is set the command to advertise other networks, right? So what this is going to look like is the command network, then an address and a wildcard mask. What this is going to do is any address that falls within the network, well, it's not the network, within the address that we put after the keyword network, this router is going to try to advertise to its OSPF neighbors. So for this case, we can clearly see that all these networks have 192.168. And then at the beginning, and then they have different .20, .30, etc. Third octets. So what we can do here is advertise to the 192.168.0.0 network, right? We can advertise to this address, which means any address that is under this, which, for example, both of these are, it'll try and advertise to its neighbors. So when this router is connected to this router, it'll try and advertise this network to here. So this router will now know how to get to here. And likewise, when it's connected to this router 5, router 1 will try to advertise the route to this network because it knows how to get here, but router 5 doesn't. So that's the idea. And if you notice, for this, our mask for this would be 255.255.0.0. However, be careful. when you're implementing OSPF, the command doesn't use the network mask. It uses what's called a wildcard mask. And you can basically think of it as the inverse of the network mask. And for example, the wildcard mask for 255.255.0.0 is actually going to be 0.0.255.255. Do you see what I'm saying? So it's the inverse of the normal network mask you'd use. And then we also need to add one last thing, which is the area. So if you have larger OSPF configurations, you can assign different OSPF areas to different like sections. We have a small section, and you always need to start with area 0, which is the core / backbone. So start with OSPF area 0. For this configuration, we're just going to make all routers part of area 0. And let's go ahead and enter this command. So this is the format of the command that you need to know. Okay, that's all for router 1. And I'm going to actually copy this because if you notice, this command is actually can be used for all of these routers. So before we need to do anything, we only have it configured on router 1. So OSPF is not going to do anything on its own. It needs some neighbors to work with. That's the entire point. So let's configure it on router 2. It's going to be the same thing. First step, router OSPF 1, router process ID and the process ID. Second step, configure the router ID. For this one, it's 2.2.2.2. And then third, paste this command in. Advertise any networks that fall under this address and network mask to your neighbors, and you're going to be part of area 0. So we enter that, and now we just wait a second. There we go. Process 1. So we get this message. So when OSPF is updating, right, when the routers are communicating and like exchanging information, it goes through like a bunch of different states. That's part of like the actual OSPF algorithm. You don't really need to worry about that. The only thing you need to know is that the full state means that we're complete. We're done. We've exchanged all the information we need. And we're ready. So let's go and check 2 things. That's it. First, we can do show IP OSPF. And this gives us a bunch of OSPF information. Really, what I wanted to show you is that our process ID that we configured is going to be right here. And then we can do show IP route. Look at the routes table. And now, look, we have a new route that wasn't there before. This O stands for OSPF. And if we look at this route, it says the 192.168.50.0 network, which is this network right here, is reachable via 192.168.10.2, which is this interface right here, which is pretty much exactly what we were expected, right? This router, because we gave it the command to advertise these 2 networks to its neighbors, has advertised the route to this network to router 2 over here. So router 2 now has a route to over here. And as we add more and more routers to OSPF, or configure OSPF on more and more routers, we'll get more and more updates. So I'm actually going to go ahead and configure OSPF on these routers 3, 4, and 5 here. Well, I'm just going to use these same commands. Router OSPF 1, router ID with the proper ID, and then this network command, this advertising command. And I'll be right back. I'll see you guys when I'm done with that. Okay, I'm back. I've gone ahead and configured OSPF on these 3 routers with the same commands that I showed you, these 3 right here. And I've also given the router some time to exchange information and let all of the OSPF connections get to the full state, which means we're done. So now that that's good, I can show IP route. I can show you guys the routing table again. And now you see we have a lot more OSPF routes, right? So I'm looking at the router ID 5. This one 5.5.5.5 right here. And as you can see, we have 3 OSPF routes. One to the .10 network, one to the .20 network, and one to the .30 network. And as you notice, it doesn't need a route here or here because they're directly connected. So what that means is that basically this router is connected to every other router of the network. It knows how to get any place in the network. And let's just, to show you that, let's go to just this random different router, exit. Let's just start pinging other networks. So ping 192.168.10.1. That's a success. Ping 192.168.50.2. That's a success. Ping 192.1.40.2. That's a success. As you can see, all these routers are now connected to basically every other router. So we successfully configured OSPF on this network. Okay, now I'm going to reset this, undo all the configurations I made, and I'll show you guys how to configure OSPF with the second method I mentioned, which is with the interfaces. Hello, so I'm back and I've reset the network to what it was originally. So I removed all of the configurations. And now I'm going to show you the second way to configure OSPF, which is through the interfaces. So let's go into router 1 here. Enable configure terminal. And let's get into interface. Let's get into G00 first. Okay, so with OSPF on the interface, it's actually quite simple, and it's only one command. So the command is going to be IP OSPF followed by the process ID, which again we'll set as 1, and then the area number, area 0, and that's it. That's your entire line. And I'm also going to configure it for G001, IP OSPF 0. And again, we have OSPF configured on these two interfaces. But remember, we need multiple devices to have OSPF configured. So let's go ahead to router 2. G000, IP OSPF process ID 1, and then area 0. And now let's wait a little bit. And there we go. As you can see, from loading to, we have OSPF in the full state, which means it's ready. Let's go to the other G00, 1, the OSPF 1, 0. And then again, let's go to router 3. T int G000. Oops, that's not int. And IP OSPF 1, area 0. And again, let's wait for it. Take a long time. There we go. It took a little longer that time. Sometimes it takes a little longer. You just have to wait for, it usually takes no more than like 30 seconds to like at most like a minute. So there we go. And I'm going to go ahead and configure every other interface with OSPF as just like last time. Okay, and here we go. So I've just gone ahead, just gone into both interfaces G00 and G001 on every single one of these routers and applied the IP OSPF 1 area 0 command. And as we can see, if we go do show IP routes, we have the same exact 3 OSPF routes on router 5 as we did with the other method, which is enabling it through the routers. So you can see that both methods yield the exact same result. And just to prove, I'll go again to, okay, let's go to this router this time. I'll use router 3 for the other time. Exit, let's ping 192.168.20.1. It works. 30, and 40. So as you can see, router 1 can reach all 3 of these networks which are not directly connected to it, which shows us that our OSPF is configured correctly and is up and running. So those are the 2 different ways to configure OSPF. In general, I think the second way is easier on the interfaces. You don't really, because you don't really have to bother with like all the network addresses and stuff. But one thing to note is that sometimes it's important to know both methods, because sometimes you're not able to use the interface method, and that's because some switches, like especially layer 3 switches, some Cisco devices just don't have that capabilities. If you try to type in this command, IP OSPF 1 area 0, it just gives you a unrecognized command, or like it doesn't recognize it. So it's not, this interface method is not on everyone and every device, and if that's the case, then you'll have to go switch to using the other method, which is on the router, the one I showed you earlier in the video. That's all for today.